Hi guys, welcome back to just a quick video that I thought I'd throw up there for you guys. I'm forever searching around when I'm building preamplifiers and driver stages for audio amps for supply. As you're probably all aware, most of the time they need a positive, zero, negative supply. I do have a transformer that I can use for an AC input. But as you're all probably quite aware, you can use positive and neutral rails from a DC supply, provided you take care of the schematic and make sure that the polarised caps are in the right place for the type of power that you're applying to it. So I thought I'd just run through a few things here. I decided that I picked up this old box, attached a feet to the bottom, already had some holes drilled in it from before somebody tried to do a previous project, but it seemed to fall nice really for what I wanted to use it for. So we'll just build this up. I don't know how far I'm going to get with the project today, but it's just something I wish to stick on the shelf, and next time I build a preamp or something that needs a split rail supply, then I've got something readily made instead of having to hack up cables and transformers and things on the fly. So we'll just go through it as it is here now. Now, I jumped into the video sort of partially through, so I do apologise to you guys, but I think I've missed all the boring stuff out. Fitted the IEC connector, fitted the fuse holder, the fan and the IEC outlet was already in place. That's basically taped up there to keep it out of the way because I find it annoying, keep flying around all over the place. Since fitted the transformer, it's a cheap transformer from China I believe, £2 odd maybe. Fitted the three banana connectors on the front for the output. Now I didn't have much choice of the colours, it's all I actually had in my drawer at the time, but we will mark them up later. So we'll have the neutral supply, the common and the positive supply. I'm hoping to use this board. Okay. I've been asked to tell all you guys that this was actually built by the wifey. Quite impressed. A little bit quick zoom in here, let you have a quick look. Not bad if I say so myself. Two regulators, one for either side. Not bad soldering too, eh? Possibly could have cleaned it down with isopropyl. But it's my project, it's not going anywhere, nobody's going to be looking inside it apart from you guys, so we'll be using that I think. Now what I do intend to do is these two potentiometers here do adjust the voltage for each side, for the neutral and the positive side, so I intend to take those out and fit them to a double gang potentiometer just here, which will do the same thing, so I can adjust the supply voltage if need be. But as you all know, preamps usually they work up a wide range of voltages. Current's negligible, little transformers to suffice for just driving that board. Okay, now also another cheap meter from China. Found it in a drawer, decided I'm going to use it. On off switch to isolate the supply. Two little LED holders just to let me know that both sides of the rail are up and operational at the time when I turn the unit on. So just while we go through a few things, these IEC connectors from China, just a bit of a warning guys, let me zoom you out here. Okay, that for all intent and purposes they're fine, not a problem. The connections seem quite strong, easy to fit. Problem is I have found on numerous occasions if you solder and your dwell time on the actual solder joint is too long, they do work themselves loose. If you're going to use IEC connectors and you're going to use it on something that you're going to value, then please buy some decent ones. Don't buy the China ones. Just my preference. With such a large shape of wedge of metal on the end, and the amount of heat that you have to apply to actually make the solder flow is very, very derogatory to the actual unit itself. It's not good. Now, because this is a plastic case, like most, shall we say, class 2 equipment. We don't have to apply an earth to the circuit, but what I am going to do, just for my own peace of mind, is I'm going to take an earth link from this unit here, and I'm going to take on this little tag of the transformer. There's some gate in here for you, just to give me that little bit of peace of mind. Well, I'll run through a few things before I start building it up. So I do apologise, I've jumped ahead, sort of jumped halfway through the video, so there's a lot that you've missed, me fitting all the items, but you didn't miss anything apart from a lot of swearing. Okay, we'll take it from here then. So, looking at the back of an IC connector, just to make things a bit clearer for beginners, and maybe for reference for other people, save yourself the trouble. Looking at the back of an IC connector, the right hand peg here is the positive, which is a live from the supply. The left hand peg is a neutral, so I'll try and get back on camera for you. And the centre pin, the largest pin, protrudes the most forward, makes first contact with the connection, and upon leaving the socket, leaves the connection last, is in the centre. I have shrink wrapped these units, no need really. I'm not going to be gaining access to this unit anytime soon, but sort as you mean to go on. Okay, one thing about these fuses, little 20mm fuse holders that you see here, one thing to bear in mind: you must, when connecting a live supply to a fuse, make sure that the positive in, the live in, goes to the bottom peg. If not, I'll explain to you what can happen, and I've seen this on numerous things, and actually I've seen this done incorrectly on quite a few bits of apparatus built by professionals, which of course I'm not one of them. But if you just put the meter on beep test here, you will see that bottom peg, okay, if I put the meter on the bottom peg there's no connection to this outer unit, which means on an instance when the supply is still plugged in and somebody decides to remove the fuse, as they're removing the fuse, any contact made with this area, it's unlikely but it can happen, is not live. If you connect the positive terminal to the outer, or shall we say the connection nearest to the front of the fuse, you have this scenario where, although you've removed the fuse and effectively the unit's gone dead, a finger touch there is in direct connection with the live supply, so just bear that in mind. Okay, so your connection from the live supply, should I say the IEC connector, has got to be on the bottom peg. So we're going to start and we're going to wire that on. Okay, I try my best to keep you in view all the time, but as you know, I'm new to YouTube, not used to all the camera handles, so we'll just see how it goes, shall we? A little bit of shrink wrap, I think, and we'll slide a little bit over the terminal. Yeah, that should do the job. We'll just snip a bit off. Slide it over the cable, push it far away down the cable so the heat doesn't affect it. Change of the glasses. And we'll poke that, hopefully, through the hole. A little bit of solder joint. So excuse me guys, we don't talk too much during this video. Seem to have mislaid the solder. There it is hiding. We'll zoom you out a little bit now, I think. You can probably see what I'm doing a little bit better that way. done, snip off the excess. And slide the sleeve over. A bit with the hot air gun, sorry camera. And we'll just heat that up, shrink it round. So that you guys can see the connection there. Excuse the noise from the hot gun. Now we are going to want to isolate the unit from the supply, so it's got to come across to the switch. A bit of cable from the drawer. Strip of the unit. As per usual, spraying. And we'll make that solder joint there. Snip off any excess cable. Same as before, we'll put a tiny bit of shrink over it. Off to air gun again, try not to bang the camera. Okay. I think we may take that out of the case. I think just for posterity, I think we'll put a little tile up there. A bit too much length on that cable. Let's take some off. So we're going to need some large to shrink that for this. That's fine. And what we're going to do is we're going to solder the connection to the transformer to the bottom of the switch before we do anything else. Makes access a little bit easier. Scissors. And we'll slide that down the cable. think before we go any further we'll just check out that switch. Really should have done it before we fitted the device, but we'll just check that it works anyway. No connection. It's fine. Slide this ring up the switch. There going again. Same. Better shrink that. Slide it down the cable. Connect the unit. Shrink wrap seems to have run off by itself. So there we have the connection to the switch. So what we'll do in a moment is we'll just check that everything's operational. But what we'll do first off is we'll just make the connection to the connection here. Like I said, it's not needed, but we're going to do it anyway. And you may even see what I mean about these cheap IC plugs, sockets, etc. The pins of a mind of their own decide to come loose because of the dwell time on the actual connection. Resoldering iron. This one don't seem too bad actually. Okay. So we could buy some nice green. Don't really need to sleeve this. It's only for looks. think we'll just send that down there to the actual connection itself. I'm not going to bother sleeving the second bit down there. Sorry guys, you can't see a lot of what I'm doing. Let's give ourselves some solder. Doesn't like flowing on this. Maybe I should have put a bit of flux on first. See how it goes. That seems to have got it. Okay, shall we give it a test? Let's see if we've got a supply. Let's see if we've got some voltage coming out of this little transformer. Now the transformer does actually say 18 volts. You can see it there, 18018. Should cover everything that we need really. But we'll just give it a go. So if I get myself an IEC cable connector. Plug it in. See what we've got. Zoom it out a little bit. Okay. Yellow should be the centre top. We have 0 there at the moment. 21.95. Exactly 18 volts, is it guys? Other side 21.96. Okay. Now of course will give us across the whole supply 43.85 volts. That's fine. Okay. Unplug the device, take away the lead, put it on one side, and at least we know we're not making any mistakes. Now what I do need to do is remove these potentiometers from the centre of this board here. But I think for the time being, just to make sure that everything's operating fine, I think we'll leave them in for now, and we'll fix the unit in situ. Okay, just give me a second, I'll find myself some screws to fix it in. screwdriver will be a lot better off, guys. Now I'm not going to put all the screws in, just for the time being. I'm going to put 2 in to hold it in place. It's not great having them close to that board, but I'm sure it'll be fine. And I'm sure in here somewhere that we'll have another screw to fit it. Magnetic. Okay, split it in quite tight. I think we'll take a bit of length off these cables here. Zoom in a little bit here. Quick tug, make sure it's nice and tight. Okay. So what we'll do at this point, we'll give it some more power and we'll check the voltage on the outputs. Take it out again. And we'll just show exactly what we've got. So now we're going to go to DC. Turn the device on. Ooh, looks like Wifey's built it properly. Let's have a look. Voltage minus 16.56 volts. On the other side, minus 15.26. Obviously there's an imbalance there. It's not a problem. I think what we'll do at this point, I think, is turn the device off. Obviously, as you can imagine, guys, the reservoir caps here are storing a lot of charge, so we'll just wait for them to die down. So how quickly they actually do that. So we've got on the output. 0.6, 0.5, 0.4, they're dropping. Pull this out. Put the lead away. So, see what I've done so far there, guys. Still have the banana connectors to wire up. They're going to go over to this side here. We'll find some relevant cable for it in a moment. Still have the display to wire up. I think we'll take the display, from the actual banana connectors themselves. Probably for just on the one side. If we get the both sides to match up on the potentiometer, then we can work from there. I'm pretty sure that within a certain tolerance we're working at the right voltage. Oh yeah, forgot to mention that I will be putting a link from the LEDs here to the front panel, just to let us know that we actually have to do an AC input. We know that both sides are operational, so we continue to use the item. Obviously they're a good signal of any faults that may occur. Hopefully not, but you never know. Okay, so what I'm going to do now then is we're going to take out the centre pots and I think we'll take some wire links to that. So we just pause the video there, guys. We'll get back to you as soon as I've taken these two units out here in the centre. We'll come straight back to the video. Right, welcome back, guys. Sorry about the quick interlude. As you can see, I've been off and I've took the printed circuit board over the other side of the workshop, because unfortunately that's where my solder sucker is at the moment. And I've connected the cables for the potentiometer for the voltage adjust and the cables for the LEDs. So we'll carry on with that then for now. First things first, LEDs can wait. Let's wire up the potentiometer. As you can probably see, there's only 3 cables here. And you're thinking to yourself, look at the potentiometer. You can see there or not, 3 legs. Well, on the printed circuit board, 2 were shorted together anyway, so then what a necessity to bring 1 cable up for that and 1 cable for the other side of the slider. Same on the other side. Okay, so we'll continue to wire that up. So get yourself some cable, bed off, solder to. Change the glasses again. I do apologise for the sound, guys, if it's not up to scratch. Unfortunately, I'm still waiting for the new camera to arrive. I'm waiting for the phone call from work to say it's here. What we're going to do with the new job, we're going to take it across both poles with the actual potentiometer. I think we'll just tin that first. See there, or not. Sorry guys, the light's terrible. If I can zoom you in. Probably see there across both. See there, from there. Booking it down with rain here, I can tell you that much in Nottingham. But thankfully it's cooled down a hell of a lot. Okay, I think at this stage we're at gating the use for the LEDs which are irrelevant at the moment. They don't play any active part in the circuitry at all, they're just an indicator. I think we'll give it a bit of power and we'll see what we've got coming out of the device itself. So we'll set DC volts. See if we can bring no, bring the meter into view. Can't quite get it in, so just believe me guys. Okay, and we'll get ourselves some power. Set the output. It's in there in a moment. .7 volts. Or thereabouts. Just to the slider. Oh, that's a bit critical, that. Down to 1.2. Okay, so we can see from there that the voltage is adjusting. We'll do the same as what we did last time. We'll turn the device off, unplug the power, take the lead away. And I think what we'll do is next is we'll wire up maybe I think the outputs to the banana jacks, and at least then you've got a visual demonstration of what's happening. So far get some power leads. Cable will do fine. Slip some back. I think what we'll do is we'll tin the end of these cables. There's a connection with the socket a lot better. We'll mark up visually with some shrink wrap exactly what cable is what. So a bit of helping hand, I think. Snip off the excess. And I think the first one that we'll do, maybe, is going to be the neutral ground. Maybe it would have been easier to have had the board out. We've got A out, centre tyres. There we go. Slide down the black connector. Sorry, shrink wrap. that one there is going to go to the green common supply. So, find a bit of green. Next one's to the blue. Shrink him up. Finally going to be the red. right connection. Okay guys, so there we have the 3 cables. See if we can thread this through. Okay, done up in there guys, but the camera decided to shut itself off. We'll carry on regardless. And get it soldered to plug. Right, so the camera decided to shut itself off yet again. Don't know why. It's on 2 bars, only has 3. But I think what we'll do is we'll just skip ahead guys, and we'll just see this in operation. Just before we go any further, might have to cut the video short. Let's give ourselves a little bit of power, shall we? Bit of a shame, really. Okay.